Hi, and welcome to our talk about Cypher query building with open source LLMs. So what we want to do is combine large language models with knowledge graphs. I'm Djordje. I'm a senior data scientist at Eviden, which is an Athos company. I work in Germany as a public sector consultant slash data scientist. So the topic of open source and transparency, etc., is really important for us, especially now with the EU AI Act. There's been some more focus on that topic as well. So I'm looking forward to telling you a bit about that and where I've used this. See, yeah, now it works. So just a little bit about the motivation of this topic. Then I'll talk a bit about the system overview of what we're doing in general. Then specifically about the ingestion part, then the query building, and I'll show you a little live demo in a Jupyter notebook about the source code, so you can have a look at that with me. And if there are any questions, I'm really happy to answer any in the end. So first of all, coming to the motivation of this talk. So we've seen great progress with large language models, and they can do a lot really well. They understand nuances in texts, so it's fascinating how much they can already do, but they have some limitations, and everyone who's worked with them has already come across them. Basically, they can't answer anything that's specific to something that, for example, your company knowledge or anything that's really new information that hasn't been trained into the model. But they sound really really confident when they make up stuff. So they will try to answer that, although they don't really have the information. Yeah, so in comes the whole topic of retrieval augmented generation, which can combat some of those shortcomings, right? If you have a question, then first you run this through an embedding model. With the embedding, usually that's a vector store. You retrieve some documents, and then you give the question and the retrieved documents to a large language model, which can then answer these, the question based on the information that it has retrieved and generate a response. So that can combat the lack of specific domain knowledge, because you can have documents that contain this knowledge. These documents can be newer than the model, so it can include knowledge that it doesn't have. And it also is a means of verifying and explaining the answer, because if you have sources, then you can refer to those sources and check back if the answer actually is in those documents, especially if you use a second model, so you can match the text of the retrieved text chunks against the generated information. But if we are using pure vector search, that has also some shortcomings. It's really difficult for a pure vector search RAG system to answer multi-hop questions on its own, especially if those involve multiple documents, because it can only answer it can only answer based on the context that it has retrieved, and usually only retrieve a certain number of say K documents. So so whenever you need to answer something that spans a lot of documents, it's probable that that with this system, it can't be answered because there's no global insight into the whole database. So for example, it won't be able to answer questions like how many documents are there in the database, or how many documents about a certain topic are there, or how many projects when you have another database. And it can't answer complex things like what is last month's most common topic, or on its own, it's really also difficult to answer stuff like what did the founder of Tesla do yesterday? Like something like that. It's really difficult to answer because it first needs to identify several parts, and then it needs to connect them. So in comes knowledge graphs, which provide this connection. Because we are at nodes 24, I won't go much into detail about what knowledge graphs are or how we store them. But in general, it's a formalized representation of knowledge, of entities of certain types. In my use case, because I'm working with a news graph or a graph of news articles. We have articles which contain text chunks, and then in these text chunks, there can be several entities that are mentioned: organization, persons, location, and these can have relations between them as well. And all of those entities and relations can also have attributes, which maps really well to Neo4j because all those entities and relations are first-class citizens. So we have a direct connection between the logical thing and how it's modeled in the database. And so the idea of RAG with a knowledge graph is basically we ask a question, and then we can either perform similarity search with a graph traversal, or we can directly build a Cypher query, retrieve relevant information, and then we answer the question with an LLM. So that's the general idea. And I'll talk a bit about how, first of all, I created a toy knowledge graph in this case, and then about how we build Cypher queries with an LLM in the second part. And I'll also show a live demo of these two parts, so you can follow and maybe reuse it in your own projects or adapt it. So the idea is first I crawl some news sites. There's a really great open source framework for doing that. It's called Fundus, developed by the University of Berlin. And it has lots of news sites incorporated, and it's really easy to use it. It's just basically 3 to 4 lines, and you can crawl specific news sites, or you can crawl all German or all English news sites, depending on what your use case is and what you actually want to do. Then we extract entities. This year, there has been great progress in doing that with lightweight models in a zero-shot way. So you basically, with this GLiNER, generalist lightweight model for named entity recognition, you just specify the types of labels you want to extract or the types of entities you want to extract. Then you provide it with a text, and it extracts it. And a very similar thing has been done for relationship extraction with Relic, which is also a really great framework for relationship extraction and also entity linking, because if you want a clean knowledge graph, then it's important that you don't have, for example, former President Trump, Donald Trump, and several entities for the same entity. Then once we've extracted the entities and relations, we store them in a graph database. In our case, obviously, Neo4j, the market leader in graph databases. Once we have this knowledge graph, we can use query building to get answers to our questions. So it's very similar to the standard RAG approach. The difference is we have the prompt, and from the prompt, we build some Cypher query. With this query, we basically query the graph database, Neo4j. We retrieve some information from that. And then with the retrieved information, we generate a response. And I'm now going to show you how I did that. First of all, a bit about the fundus. Restart kernel. Okay, that will just take a second, and then we can continue. So as you see, it's really easy to set up this fundus. You basically just specify what you want to crawl. In my case, because I'm focusing on the German market, we have German and British news sites. Then we specify a crawler, and we basically just say, okay, crawl this, and we get articles back. Now, obviously, this has to be transformed in a pipeline so that I only get the information that I actually want, and I store it in the database. So here, now for all those who aren't German, there has been some political turmoil in Germany because the chancellor has just dismissed the finance minister. So there will probably be new elections next year, early elections. So there's lots of German news now about political topics. But you can see that it's structured information that we can use next to the unstructured text. So what we can also see, we have a news graph client. We can see we have different sources that are all created from crawling these news sites. And we can also see how this works here with an entity finder, GLiNER, really easy to use. We import this, and then basically we have the relevant labels specified. In my case, it's organization, person, and location. And then for all the retrieved articles, we can find here Scholz is a person, that's correct. The text also mentions the FDP, which is a party, the person, Olaf Scholz, several other persons, another party, different parties. Now we also have Donald Trump, because obviously this has been on the same day as the election in the US. And the other one you can see also mentions several similar people, because this has been today's main topic. So you see an organization as the federal government. You also see here there's justice, the Minister of Justice, and different other ministers. So you can see that. And similar here, relation extraction is also really simple. Basically, you just have import relic. We specify a pre-trained model, instantiate that, and then you give it a text, and it will also retrieve the relevant or the relevant relations in that. And once we've done that, we've retrieved it, we can have a look at the triples that are in there. So basically, here we have Volker Wissing and the FDP, which is party, and it tells us, okay, we have the subject, Volker Wissing, the object, FDP, and we have the label in between, member of. And we format it in a way that we can also put it in the database in a standard form. So having done all that, we can then go to the query building, where we're using Haystack as a framework. It's really easy to define custom pipeline components in Haystack. That's why I like it. So for example, here I used an entity retriever. Once I once the entity finder has found some entities, we query the database to see if there are similar entities, because sometimes if you have a typo, or if for example, you have Donald Trump and then Donald Trump Jr., naively it will say those are different entities, but to give the LLM some context, we retrieve all that are in a similar. And we have a Cypher retriever, just a really simple thing to actually get the results from the database. So we have that. We define the prompt templates. Now, I don't want you to read all this, but the important bits are we have two prompts, once for the Cypher generation and then for the answer. And for the Cypher generation, we obviously need to give it the database schema so it can create informed Cypher queries. I spoke about this. We have retrieved some entities that we found in the text, and then we give it some few short examples. So that's basically it, and then it generates a Cypher query with that information. For the answer, that's a bit more similar, or a bit more simple. We give it the query to have some context. We give it the context that we retrieved on the database and the question, and it generates the answer. Then we set up the query pipeline. The important parts here are we have pipeline components, which basically form a graph themselves, and they are connected with edges. So basically, when we visualize this, oops, kernel has crashed somehow. Let's see if it works now. But basically, when we run this, we have a query, and then we generate a graph. And what's also nice about Haystack is you can visualize this. So you can see, okay, there's a text, we find entities, we retrieve these entities to get a list that we can put in the Cypher prompt. We build the Cypher prompt, and then with the Cypher LLM, we generate the query. We retrieve the data from the database, then build the answer with the question and the context, and let the LLM generate the final answer, basically. Now let's see if it has worked. Sorry for skipping back and forth. I hope now it doesn't crash. Okay, yeah, seems good. There's a green check mark. then we can generate the Cypher queries. So basically, oops, I can close that. So if we ask a question like, are there news about specific members of a specific party, then it runs. Here's some, I printed some of the steps in between. So it looks for chunks that mention the organization SPD. We retrieve several information about that. And then the LLM tells us, yes, there's news about it. Talks about Nancy Faeser, the Interior Minister of Germany, Jens Bröckner. This is apparently some local news. Then there are some mentions of general, because some of them are critical about some political stances, and then about Olaf Scholz and Saskia Esken, who's high-ranking member of the SPD. So this is pretty nice context. And with that, I think my talk is finished so far, and we can go to the questions and answers. If that's correct, Bradley, I think we are through with the time, right?